Welcome all to this lecture series on ESP32. I am Vibha working at Entity, Intelligent Devices and Smart Solutions. In this lecture, we will learn about static task creation. Till now, all the tasks were created using xTaskCreate and xTaskCreate pinned to core. The task's memory allocation was done from FreeRTOS heap at the runtime. We have seen this type of task creation a lot. There is one more variant of task creation, xTaskCreateStatic. In this, the stack and TCB are allocated at compile time. The memory is not allocated from the heap. On ESP32, static task allocation has limited use case for application. ESP32 has heap and actually it has a lot of it. ESP-IDF itself uses lot of dynamic allocations. The Wi-Fi, TCP, IP, BLE, Bluetooth, OTA are all entirely dynamic. Static tasks mainly help in deterministic system like medical application or automotive use. Static tasks are useful when the heap available is small or there is no heap in the smaller MCUs, or where compile time memory guarantees are needed, or when strict safety certifications are needed like medical devices or automotive use. Let us create a static task. ESP32 mostly we will be using dynamic tasks. Start Visual Studio Code. Then open the folder we were working on. Create a new main file. Name it suitably. Static task main.c. Then open cmaglists.txt. Remove all other files except static task main.c. Then close cmaglist.txt. We'll include the header files as include stdio.h, as include FreeRTOS directory, FreeRTOS.h, as include FreeRTOS directory, task.h. We will define a macro, stack size. We will keep 2 kilobytes. Static. Stack type T. Task stack of size, stack size. So this stack type T is alias to uint 8T. This we have discussed in lecture 4 part 0 in data types and coding style in FreeRTOS. It's a data type used to represent one stack entry in FreeRTOS. So think of it as the smallest unit the FreeRTOS stack is made of. So when we are writing task stack size of 2048, we actually mean the stack size of 2 kilobytes. Then static task T task TCB. Static task T is a data structure provided by FreeRTOS to support static task creation. FreeRTOS hides its real internal TCB, but when a task is created statically, the application must supply memory to it. Static task T is therefore a placeholder whose size and alignment are guaranteed to match the internal task structure, regardless of processors or configuration. Static task T definition is not of much importance, but understanding TCB is of greater importance. So let me explain what is TCB. I will give a simple flow diagram for TCB. When a task is created, it means creation of TCB and stack. Or TCB will have a space for task ID. It will have a space for priorities, storing priority. Stack pointer. This stack pointer will store the top address of stack in program counter and place to store processor registers. Next step is initialize stack pointer with top of stack. This pointer with this address. Then TCB is inserted into the ready queue. After that, when a task is switched or when the task is run, this scheduler selects the TCB. So this is creation of task. When we create task, TCB and stack to memory blocks are allocated. In TCB, it will store all the values that will help it to return and switch the task. Let us see what happens when a task switch happens. TCB is used in the context switching. Suppose there are two tasks. TCB stack of task A, task B, TCB and stack. And suppose task A is running. Then interrupts happen or a tick has happened. Then it is a time for a task switch from task A to task B. So then the state of the task A, that is TCB, its ID, stack pointer, program counter and register values all will be populated with the current state of the task. Register values will be stored in the TCB. Then stack pointer, program counter all will be stored here in the TCB. And similarly, from the previous switch, the task B will have all the states populated, register values populated. So these will be brought back and loaded such that now task B will be running. what will happen is save CPU registers into TCB of task. Then select next TCB of task E. Then restore the register values from TCB of task B, and at the last we will have task E running on the CPU, and thus the task switch will happen. This is context switching, and this way tasks are switched. So let us go back to the program. We will create a task entry function void static task void pointer parameter infinite loop for the task. Inside the task, we will just print a statement and put a delay of 1 second. Static task running. Then delay of 1 second. PDMS to ticks. This will convert milliseconds to number of x. Then we will create our app main function. The signature of the static task creating function is task name x. Let us build the program so that our intelligence is working. Build the project. In our last application, in the idle task and idle hook lecture, we checked the idle hook function, use idle hook function. We need to uncheck that. So we will open the IDF terminal, press Ctrl Shift T, then open ESP-IDF terminal, then idf.py menu config. Press enter. Then go to component config. Then FreeRTOS. Kernel. Config use idle hook. Here press space to uncheck this. Now it is unchecked. Press S to save. Enter. Now press escape. Press escape. Again escape. Again escape. Again escape. Again escape. Now press Y to save. Now we'll again build it. Build was successful. We will start creating the task. So X task create static pinned to core. The first argument is task entry function. Static task. There is some typo and some name for the task. Will enter static task. Then we need to put the start depth, stack size. We won't pass any parameters. In priority, we will put it as 1. In here, we need to pass our stack pointer. We have made one array. We will just pass the name of it. Then we have to pass the TCB, static task T pointer. This TCB. It is of type pointer. We will pass the address. Then we will run it on core 1. I hope this is fine. We'll build the program. Pass it. Pass it. Monitor it. So the static task is running. This task was created at the compile time and the memory was allocated at the compile time. This is just for completion's sake. We won't be using static task much as we have lot of heap memory in ESP32. But still, in case of stringent safety requirement needs, we will need static task creation such that our stack is guaranteed. So that's all from this lecture. We'll see in the next lecture. Thank you.